All right, in this video, I'm gonna go over or we're gonna start to get ready to learn the power reduction and the double angle formulas. Um, they become super essential as we move along in multivariable calculus because we convert to trig things all the time, and they just show up repeatedly. So my goal is to integrate trig integrals with even powers. What I mean by that is things like the integral of sine squared x dx, or maybe say the integral of cosine to the 6x dx, or even something like the integral of sine squared x times cosine to the 4th x dx. As you can probably imagine, this one is the easiest of them, and these two are going to get pretty complicated pretty quickly. But they show up all the time because of the nature of how double integrals work when we get there. So in order to do this, we need to do a bunch of work with triangles and trig identities. But I'm going to go through, and I'm going to have you walk through that process. But I just want to tell you what the formulas are from the get-go so that you can see where we're going, right? I'm going to show it to you now, and then we're going to do a whole bunch of work to get to that spot. So the ones that we use the most are the ones to actually change this. They're called the power reduction formulas. So the power reduction formulas, there's one for sine and there's one for cosine. The power reduction for sine is that sine squared x is equal to long fraction bar 1 minus cosine of 2x all over 2. And then the corresponding one for cosine is cosine squared x. It looks very similar, is equal to 1 plus cosine of 2x all over 2. So notice the sine squared one is almost exactly the same as the cosine squared one, except for I've got a negative and a positive. Now you are gonna do the work to show why this is true. I'm gonna guide you through that with separate videos, but I want to give you a way to remember this. You all should know the derivatives of sine and cosine. Sine derives to positive cosine, cosine derives to negative sine. Here, it would be nice if they had the same relationships, but they're flipped, right? Sine goes to, in derivatives, sine goes to positive, cosine goes to negative. Notice here it's the opposite. Sine goes to negative and cosine goes to positive. So if you can remember the 1 cosine 2x all over 2, all you got to do is figure out which one's positive and negative. And hopefully that little trick of it's the opposite from the way a derivative works is enough for you to help, or is enough to help you remember it. So I'm going to show you the double angle formulas in a moment. All right, so the double angle formulas, which we can prove in similar ways. There's one for cosine and there's one for sine. So sine's double angle formula says sine of 2x is equal to 2 sine of x times cosine of x. A lot of times there will be thetas in there instead of x's, but I'm using x's in this video. And the double angle formula for cosine is that cosine of 2x, there's the double angle, doubling the angle there, is equal to cosine squared x minus sine squared x. There's a couple different forms of this one, but that's the one that I'm going to give you right here. And to be honest, the ones that matter the most for where we're going are these power reduction formulas. Let me explain why. If I asked you to integrate this, it doesn't have an odd piece here. If it had an odd piece, we could do some little tricks with sine squared and cosine squared. But so I can't do that. I'm kind of stuck. So what I need to do is reduce the power. So I use the power reduction formulas. Notice if sine squared is equal to this is integratable. I could write it as 1/2 minus cosine 2x over 2, and that's totally integratable with some pretty simple u sub. So the way that I integrate this is I reduce the power down to this form, and then I can do the integral. So the last thing that I want to say here is that we need a particular formula in order to get to all four of these. It is called the sine addition angle addition formula. So I'm going to write that here. What that says is that sine of a plus b is equal to, and it's kind of long and complicated, sine of a times cosine of b plus cosine of a times sine of b. Notice sine A, sine B, cosine B, sine of A plus B. There's also a cosine angle addition formula that's very similar and can be proved in almost the exact same way. So what I'm going to have you do now is you're going to go off and you are going to work on showing why this piece has to be true. After you show that this piece has to be true, then we can do some little tricks to get to power reductions and the double angles. So I will see you in the next video after you do some work with this one.